The Shiva Nature of Science. Exploring the multiple forms of gathering knowledge. Virtuality 2. Any real virtual reality enthusiast can look back at VR science fiction. It's not about playing games. The Matrix, Snow Crash. All this fiction was not about sitting in a room playing video games. It's about being in a parallel digital world that exists alongside our own, communicating with other people, playing with other people. Palmer Luckey. Science is essentially an anarchic enterprise. Theoretical anarchism is more humanitarian and more likely to encourage progress than its law and order alternatives. Paul Feyerabend. The scientist is not a person who gives the right answers. He's one who asks the right questions. Claude Levi-Strauss. We are trying to prove ourselves wrong as quickly as possible, because only in that way can we find progress. Richard P. Feynman. It is one of the curious oddities of our time that we talk so much about the scientific method as if it is one singular entity when, in point of practice, it is anything but. The ultimate linchpin in science is decided not by how we go about doing it, but about how well our hunches, observations, and results tally with the universe we observe, and in turn, how such intellectual lurches compare and contrast with other competing stratagems in terms of yielding more, not less, information. The very word science, derived from the Latin scire, see the Oxford English Dictionary for more on its etymology, is rather open-ended and simply means knowledge. Hence, it is along these lines that the acerbic philosopher Paul Feyerabend long argued that science isn't really a method at all in the strict sense of that term. Rather, it is a label we use to describe the testing and verifying of differing ideas and maps we have about the world, and allowing such templates to strenuously compete with one another. How we actually do science is invariably much sloppier than we might at first suspect, but which every scientist worth his or her salt knows too well. This is why Richard Feynman spoke so frankly when he said that the first thing we do when we try to figure out how something works in terms of physical laws is by guessing. We then check to see how well our particular guesses hold up. Given this modus operandi, we soon realize, along with T.H. Huxley, that we are all scientists at some level, whether it is trying to figure out how to bake a cherry pie for Christmas Day or fixing an old pool heater that has seen better days. Yet, sometimes certain authors, in their haste to criticize some reductionistic aspects of science, resort to misleading caricatures about such an endeavor, neglecting in the process how truly accessible and messy the scientific endeavor can be. For instance, in a recent article, in defense of Ken Wilber's Integral Theory of Everything, published on Integral World, H.B. Augustine opined that science is destructive in character because it serves to disprove and criticize, which of course is neither accurate nor insightful. Astronomy, to take just one obvious example from the sciences, isn't so about disproving anything as such, but rather about discovering vast new vistas. There is nothing destructive per se when Edwin Hubble looked through his telescope in the latter part of the 1920s and observed a redshift in the electromagnetic spectrum, whereby light from distant stellar objects appeared to move away from his point of inquiry. Hubble's record only served to confirm what the Belgian priest and physicist Georges Lemaitre had deduced 2 years prior from Einstein's general theory of relativity, which is that the universe must be expanding. Yes, it is certainly the case that reductionism is part of science, but so is almost any human endeavor, including the very use of symbols, from Mandarin Chinese to Sanskrit, and vocal sound waves to communicate and explain complex features found in nature. But to suggest, as Augustine naively does, that the scientific method is all about divide and conquer, is to overlook the fantastic panorama of how we go about gathering knowledge. Contrary to popular misconceptions, nothing is holding any would-be scientist back from taking a holistic or integral approach to his subject. Indeed, many great theorists have already done exactly that, ranging from such Nobel laureates as Ilya Prigogine, who focused on complexity and dissipative structures, to Gerald Edelman, whose pioneering work on the brain and consciousness is underlined with a deep appreciation for the emergent properties of qualia and self-reflective consciousness, which he refers to as second nature. The noted physicist Steven Weinberg points out that a distinction should be made between grand reductionism and petty reductionism, since the latter, he argues, is not worth a fierce defense. Sometimes things can be explained by studying their constituents, sometimes not. When Einstein explained Newton's theories of motion and gravitation, he was not committing petty reductionism. His explanation was not based on some theory about the constituents of anything, but rather on a new physical principle, the general principle of relativity, which is embodied in his theory of curved spacetime. In fact, petty reductionism in physics has probably run its course. Just as it doesn't make sense to talk about the hardness or temperature or intelligence of individual elementary particles, it is also not possible to give a precise meaning to statements about particles being composed of other particles. We do speak loosely of a proton as being composed of 3 quarks, but if you look very closely at a quark, you will find it surrounded with a cloud of quarks and antiquarks and other particles, occasionally bound into protons, so at least for a brief moment we could say that the quark is made of protons. Indeed, the renowned Santa Fe Institute, founded by such luminaries as Murray Gell-Mann, Nobel Prize winner for his theoretical work on elementary particles, and more popularly known for his naming of quarks, supports a whole host of non-reductionistic scientific studies. Thus, it is ironic that in prematurely trying to criticize a particular aspect of science, among a host of varying other aspects, one would resort to reducing all of science into a cheap and wholly misleading soundbite to champion its purported alternative. No, the truth is that the human drive to gather knowledge and then openly compare and contrast such theoretic and observational templates is an expansive field and one which allows for all sorts of imaginative pathways. In other words, science is a quest with many methods, and not just one. Analogously, science is like the Hindu god Shiva, who is often depicted with multiple arms signifying his illustrious powers to take on different forms and act in manifold ways. While it is certainly true that one aspect of his nature is destructive, it is also true that Shiva is depicted as a transformer. Accordingly, Shiva has numerous aspects ranging from beneficent to frightening. But one of his more popular aspects is as a universal dancer, perhaps best illustrated artistically in bronze casts as Nataraja. Science like Shiva cannot be confined to only one aspect. To focus on only one feature of science to the exclusion of others, to misleadingly characterize its multiform nature, and to elevate another method to a higher ranking is to perpetuate a falsehood. Ironically, even though we value science for many of the predictions and technological inventions it makes from time to time, we imprison its potential value when we limit its Shiva-like nature. As Lewis Thomas insightfully pointed out in his 1980 tome, Late Night Thoughts on Listening to Mahler's Ninth Symphony, science is useful, indispensable sometimes, but whenever it moves forward, it does so by producing a surprise. You cannot specify the surprise you'd like. There are, in sum, innumerable ways to gather knowledge about the cosmos we inhabit. What makes science so powerful is that it allows for such findings to be publicly aired and scrutinized and tested, not only with the world it is trying to understand, but with other vying alternative models which differ from each other. Perhaps science's greatest contribution is that, at its best, it is open to refutation and is thereby open to change. Carl Sagan summarized it thusly: in science, it often happens that scientists say, "You know that's a really good argument. My position is mistaken." And then they would actually change their minds, and you never hear that old view from them again. They really do it. It doesn't happen as often as it should, because scientists are human and change is sometimes painful. But it happens every day. An often told joke concerning Albert Einstein, clearly fictional, perhaps reveals best the tentative nature of science and its findings. Student: Dr. Einstein, aren't these the same questions as last year's physics final exam? Dr. Einstein: yes, but this year the answers are different. Postscript: ironically, The greatest strength in science is that it is always open to being wrong. That is precisely why it is a progressive enterprise, since it is constantly revising and updating its previous models. Moreover, the study of nature is not limited to any one algorithmic procedure, but is an open-ended inquiry that allows and encourages multifarious approaches. The caveat is that all findings must be open for testing, experimentation, and, hopefully, falsification or verification.